Hello students, welcome to LUSSAC'S Classes YouTube channel. In this video, we are going to deal with one interesting and important concept, that is Gay-Lussac's law. And we are also going to solve the problems based on this law. This is very interesting and important concept from chemistry of class 10 of ICSE syllabus. So in this video, I will explain you what is the meaning of this law in simple words and how to apply this law while solving the problems. And while solving the problems, I will be also sharing few important tips which will help you to score best marks in your exam. So I request all my viewers, all my dear students, that don't skip this video in between. Watch each and every example properly so that you will understand the concept deeply, properly. Okay, so before I start explaining the law and the problems based on that, here itself I would like to give you one important tip. Whenever you study any concept, okay, study the concept properly instead of studying only the questions based on that. This is the common mistake what the students do. Most of the students do this mistake. They study question answers. They study one by one problem, but they forget what is the base of that. So what I suggest to the students is study the basic concept. Once you understand that basic concept thoroughly, properly, you can answer any type of question asked based on that concept. You can solve any type of problem which is going to be based on that concept. So instead of focusing only on the question answers, focus on the basic concept. So this is the very important tip which you have to follow in each and every subject. So now let's start with the Gay-Lussac's law, which is the main concept of our today's video. So first of all, what is this Gay-Lussac's law? When the gases react, they do so in volumes which bear a simple whole number ratio to one another and to the volumes of the products, if gaseous, provided the temperature and pressure of the reacting gases and their products remain constant. So what exactly this law mean to say? The first thing, whenever any chemical reaction takes place, there are some reactants, either one or more reactants and one or more products. So chemical reactions in short involves reactants and products. So first of all, this law is applicable when reactants as well as products are in gaseous state. Okay, so the first condition, it should be in gaseous state. And the second thing they say, whenever they react in the ratio of their volumes. And the condition required here is the temperature and pressure at which the reaction takes place right from start to end, it is going to remain constant. So first of all, it is applicable only when the reactant and products are in gaseous state and temperature and pressure is going to be constant throughout the reaction. So this I would like to explain with one example. Before we start the actual word problems, I would like to explain this Gay-Lussac's law with one simple example. Now here, one simple example. Hydrogen plus oxygen gives us H2O. Now whenever we come across H2O, immediately it comes in our mind that it is the formula of water. But don't forget that water exists in solid state, liquid state as well as gaseous state. And when we talk about the LUSSAC'S law, whenever we come across this H2O, it's not the liquid water. Remember, it's water vapor. Okay. Now regarding this, one more important tip I am going to share later. So here, just have a look at this reaction. The first thing, reaction is not balanced. So now here, one more important thing, what you have to keep it in your mind is, whenever you solve the problems based on the Gay-Lussac's law, and when you write the reaction, it should be always balanced. Yes, or else you will not get the correct answer. So let us balance this reaction as it's quite simple reaction. Yes, it's balanced now. Now what is the meaning of this? 2H2 plus O2 gives us 2H2O. So the meaning of this is 2 volumes of H2 reacts with 1 volume of oxygen, and this gives us 2 volumes of H2O, water vapor. Means here the ratio is 2 is to 1, and here we get 2 volumes. And the condition here is reactants as well as products are in gaseous state. Temperature and pressure is going to remain constant throughout the reaction. So in simple words, this is Gay-Lussac's law. Now when we start solving the word problems based on this law, you will clearly understand the meaning of this law. So now without wasting time, straight away let us go to the first problem based on this law. The first problem is 450 centimeter cube of carbon monoxide and 200 centimeter cube of oxygen are mixed together and ignited. Calculate the composition of the resulting mixture. So here what is the reaction? Carbon monoxide is reacting with oxygen to give carbon dioxide. So let's write first reaction. So here carbon monoxide plus oxygen, this gives us carbon dioxide. Okay, reaction is not balanced. We have to balance the reaction. Yes, now the reaction is balanced. So according to the Gay-Lussac's law, first let us write the ratio. So here 2 volumes of carbon monoxide is reacting with 1 volume of oxygen to give us 2 volumes of carbon dioxide. Now what is given in this problem? So here they have given that 450 centimeter cube of carbon monoxide is reacting with 200 centimeter cube of oxygen. Okay. Now how to find out the product? Okay, what is the volume of the product? Now in this case, first of all, we know that carbon monoxide is in 2 volumes and oxygen is in 1 volume. Okay. Let us first solve this. Now here 1 volume. Okay, here oxygen which is equal to 1 volume, this is equal to 200 centimeter cube. Now 450 centimeter cube of carbon monoxide is present here. But is this reaction going to use the entire 450 centimeter cube of carbon monoxide? Let's check this. So here carbon monoxide is 2 volumes. So if 1 volume corresponds to 200, so 2 volumes is equal to 2 into 200, that is 400 centimeter cube. So though we have 450 centimeter cube of carbon monoxide, according to Gay-Lussac's law, this reaction is going to use only 400 centimeter cube because oxygen available with us is only 200 centimeter cube. So this is going to react only with the 400 centimeter cube of carbon monoxide. Now what about the product? Product is carbon dioxide and we get 2 volumes of this carbon dioxide. 2 volumes means 2 into 200, that is 400 centimeter cube. So what is the question here? We have to find the composition of the resulting product. So here product is carbon dioxide. Okay, final product here is carbon dioxide and we get 400 centimeter cube of carbon dioxide in this reaction. Now suppose if they ask what is the volume of unused carbon monoxide. So here we have 450 centimeter cube of carbon monoxide. So here let's write unused carbon monoxide. So altogether we have 450. From this 400 is used and 50 centimeter cube is unused. This is not asked in this question, but if you practice different examples based on this Gay-Lussac's law, you will come across like this type of questions. So one more tip I would like to share here is that read the question properly. Read the question properly. What exactly is asked in that question, you have to find out that answer. So here this completes our first problem based on this law. As we go on solving different examples, you are going to become 100% perfect in this law, and I am sure you are going to score full marks in the problems based on this law. So now let's move to the second problem based on this law. Second problem is 1 volume of nitrogen combines with 1 volume of oxygen to form 2 volumes of nitric oxide. Calculate the amount of each reactant required to produce 250 ml of nitric oxide. Now, even this question is not at all difficult. It's simple question. So here what they say, nitrogen reacts with oxygen to form nitric oxide. Here, 1 volume of nitrogen reacts with 1 volume of oxygen to form 2 volumes of nitric oxide. They have mentioned in the problem itself. And if we check here, this is balanced reaction. So now, 1 volume of nitrogen, 1 volume of oxygen, this gives us 2 volumes of nitric oxide. Now here the question is that what is the volume of the reactants required to produce 250 ml of nitric oxide. So now here 250 ml. Okay, the total volume of the product is 250 ml. And what is the volume of this 250 ml means we can say what is the ratio? It's 2. So here the nitric oxide which is formed is 2 volumes. And this 2 volumes is equal to 250 ml. So in this reaction, what is going to be the value of 1 volume? So if 2 volumes is equal to 250, 1 volume is equal to 250 upon 2, that is 125 ml. 1 volume is equal to 125 ml. So we require 1 volume of nitrogen and 1 volume of oxygen. So here volume of the reactants required. So here first reactant required is nitrogen, that is 1 volume, and this is equal to 125 ml. Next reactant required is oxygen, 1 volume, which is equal to 125 ml. This example was quite simple. This was very easy example based on the LUSSAC'S law. So hope even this example is quite clear to you. Let's move to the example number 3. Third example, what volume of oxygen would be required to burn completely 400 ml of acetylene, and also calculate the volume of carbon dioxide formed. So here acetylene is burning in presence of oxygen. Burning means combustion, oxygen is essential, and this is forming carbon dioxide and water. So first let's write the reaction. It's acetylene. Acetylene is nothing but ethyne, C2H2, reacts with oxygen. This gives us carbon dioxide and H2O. This is reaction which is not balanced. So we have to balance this reaction. This is balanced reaction. 2C2H2 plus 5O2 plus 4CO2 plus 2H2O. So we don't have any formula or any rigid method of balancing the reaction. For balancing the reaction, we use hit and trial method. I'll share the link of that video in the description box, which will help you to balance the reactions. So now this is balanced reaction. So now let us write the ratio of the volumes according to Gay-Lussac's law. So here 2 volumes of acetylene, that is ethyne, it reacts with 5 volumes of oxygen. This gives us 4 volumes of carbon dioxide and 2 volumes of water vapor. It's H2O. It's water vapor. Now, what is the given data and what is the question asked here? Now, here the question is that how much oxygen is required to burn 400 ml of acetylene. Okay, how much oxygen is required here and how much carbon dioxide is formed in this reaction. Okay, we will solve this. Now, the first thing what we have to do here is find the value of 1 volume. What is equal to 1 volume in this reaction? So here C2H2. Okay, this is present in 2 volumes. 2 volumes of C2H2 are utilized in this reaction, and here the volume of that is, means actual volume is 400 ml. So 2 volumes is equal to 400 ml. So 400 ml is used in this reaction. So what is the value of 1 volume here? Okay, so if 2 volumes is equal to 400, 1 volume is equal to 400 upon 2, that is 200 ml. 1 volume is equal to 200 ml. Now the question is how much oxygen is required for the complete combustion of this 400 ml of acetylene. Oxygen required is 5 volume. So here oxygen required is 5 volumes, and now we know that 1 volume is equal to 200 ml. So oxygen required is 5 into 200, which is equal to 1000 ml. 1000 ml of oxygen is required. And our next question is, what is the volume of carbon dioxide formed in this reaction? Carbon dioxide formed here is 4 volumes. So 4 into 200, as 200 is the value of our 1 volume here, 800 ml. And suppose if they ask the volume of water vapor formed here, or if they ask what is the volume of the products formed in this reaction, we know 1 volume is equal to 200. We have 2 volumes of water vapor, so multiply 2 into 200. So volume of water vapor formed is going to be 400 ml. This is not asked, so we will not mention here. So here oxygen required here for this reaction is 1000 ml, and carbon dioxide formed is 800 ml. So even this reaction was not so difficult. So as I said, if you understand the basic law, the basic concept, if you exactly understand the pinpoint of any concept, then any type of question based on that concept is going to be very easy for you. And what is the pinpoint of these problems? We have to find out the value of 1 volume. Whatever data is given to us, write down the ratios of their volumes, and we have to get the value of 1 volume. Once we get that, other things are done. Other things are very easy to find. So here we complete third problem. Let's move to the next problem. Problem number 4. 3000 cc of oxygen was burnt with 600 cc of ethane. Calculate the volume of unused oxygen. Now here ethane burns in presence of oxygen. Ethane, C2H6 burns, oxygen is used, and it forms carbon dioxide and water vapor. Equation is not balanced. We have to balance this equation. In exam, they may or may not give this reaction. If they give the reaction, it's well and good. If they don't give the reaction, it's not so difficult to write down the reactions. So let's balance this reaction, because balanced reaction is the first requirement to solve the problems based on Gay-Lussac's law. Balanced reaction: 2C2H6 plus 7O2 gives us 4CO2 and 6H2O. So this is the reaction here. 2 volumes of ethane combines with 7 volumes of oxygen to form 4 volumes of carbon dioxide and 6 volumes of H2O. Now here what they say, that out of 3000 cc, here it is 3000 cc of oxygen is given, and how much oxygen is required for combustion of 600 cc of ethane. We have 3000 cc, we have to find how much oxygen is going to be utilized and how much oxygen is going to be left unused. They are not asking us the volumes of the products. So now here C2H6, 2 volumes, which is equal to 600 cc. So 1 volume is equal to 600 upon 2, that is 300 cc. Now we got the value of 1 volume. Next part is very easy. Here oxygen which is utilized in this reaction is 7 volumes. Now we know the value of 1 volume, that is 300. So what we have to do? 7 into 300, which is equal to 2100. And how much oxygen we have here? We have 3000 cc. We have 3000 cc of oxygen. From this 2100 is used. So 900 cc of oxygen is left unused. So in this reaction, unused oxygen is 900 cc. They have not asked the volumes of the products, so we will not find. But let's calculate it orally. Value of 1 volume is 300. So carbon dioxide formed here will be 4 into 300, that is 1200 cc, and water vapor 6 into 300, that is 1800 cc. So if they ask, you can easily write that. So here we complete problem number 4. I hope the problems are becoming very easy for you. Now I think you are gaining confidence. Yes, I can solve the problems based on this law. It's not at all difficult. Yes, I will score full marks in the problems based on this law. So now let's solve 5th problem. In this video, I am going to solve only 5 problems. So 5th problem is going to be the last problem of this video. So let's move to the next problem. That is 5th problem. Problem number 5. 60 cc of oxygen was added to 24 cc of carbon monoxide and the mixture ignited. Calculate the volume of oxygen used up and the volume of carbon dioxide formed. Now here carbon monoxide is reacting with oxygen to form carbon dioxide. Reaction is not balanced, we will balance it. This is balanced reaction. 2CO plus O2 gives us 2CO2. Carbon monoxide reacts with oxygen to give carbon dioxide. So here ratio 2 is to 1, 2. So 2 volumes of carbon monoxide reacts with 1 volume of oxygen, and this gives us 2 volumes of carbon dioxide. And what is given here? Here in this reaction, they are adding 60 cc of oxygen to 24 cc of carbon monoxide. So here 24 cc of carbon monoxide is used in this reaction, and this undergoes the reaction with oxygen to form carbon dioxide. So as per Gay-Lussac's law, here this carbon monoxide is present in two volumes of carbon monoxide. And what is the actual volume of carbon monoxide here? It's 24 cc. So what is going to be the value of one volume? It's 12 cc. So now for this carbon monoxide, only one volume of oxygen is going to be used to form two volumes of carbon dioxide. So here oxygen used is only one volume, which is equal to 12 cc, and carbon dioxide form is two volumes. So this is 2 into 12, that is 24 cc. So now what is the question asked here is that how much oxygen is going to be used up here and what is the volume of carbon dioxide formed. So here oxygen used in this reaction is only 12 cc and carbon dioxide formed is 24 cc. Suppose if they ask what is the volume of unused oxygen. Oxygen used in this reaction is 60 cc. From that 60, only 12 is used here. Okay, only 12 cc is used. So 60 minus 12, 48. 48 cc of oxygen is left unused. This is not asked, so we will not write. Only for your understanding, I explained you in this problem. As I said, read the problem properly. Check what is given. Write down the ratio of the volumes properly. Find out the value of one volume. Once you get the value of one volume, accordingly you can find the value of the other things in the reaction. So here we complete 5 problems, and the next problems, which are a little bit more interesting, we can say, will be solved in our next video. So to get the updates of that video, you have to subscribe our channel. So once we upload the video, you will get the notification of that video and you can immediately watch the video of such interesting concept. So my dear students, don't forget to subscribe our channel, that is LUSSAC'S classes, and I would be very grateful to you if you share this interesting videos among your friends. My dear viewers, my dear students, thank you so much for watching this video.